All right, in this video, I'm going to continue my discussion of classical test theory, and I'm going to talk about the two definitions of classical test theory, otherwise known as classical true-score theory. So here are the two definitions. We'll jump right into them. The first is of parallel tests, and that states that two tests are parallel, x and x prime, if they satisfy the five assumptions of classical test theory. Those are the five assumptions that we've encountered before. They include that the obtained score equals the true score plus the error score, that the expected value of the obtained scores equal the true scores, and then those three housekeeping equations. And if t, the true scores on the first test, equal t prime, the true scores on the parallel test, and the variance of the error scores equal the variance of the error scores on the parallel test. Now we'll come back and talk a little bit more about this, but you do want to make do be sure to make a notation of those two additional requirements, that the true scores are equal across both the tests and the variance of the error scores are equal across both the tests. And we will come back to these parallel tests in a moment, but let's just take a look at this essentially tau equivalent test definition also. A bit less important here, but let's read through it. If two tests have observed scores x1 and x2 that satisfy the five assumptions, and if for every score the true scores on one equal the true scores on the other, plus a constant c, then the two tests are considered essentially tau equivalent tests. And what if you think that this is basically saying that you can have parallel tests where the true scores are slightly differently calibrated? That is what this is saying. This is just another, it's like a parallel test, but the true scores, one test measures the true scores slightly higher than the other. And nowadays, this is not so important. So I think what we're going to do is to kind of skip over this essentially tau equivalent test definition. You should know it's there. But let's come back to the parallel test definition, which is important today, both for understanding the history of the field and for understanding how the field works today and some of the innovations that are in the field today. Before we go on to those, let's also make a note of the nomenclature or the notation that we're using here. If x is a score on test x, then x prime is the raw score or the obtained score on the parallel test. T we use for the true score on test x. T prime is the true score on the parallel test. E is the error score on test x, and E prime represents the error score on the parallel test. Okay? But this raises a question. I mean, we have this definition of parallel tests, but wait a minute. If the true scores are on one test, the initial test, are the same as the parallel test, as the true scores on the parallel test, just exactly how do we know that? Because I thought that true scores were hypothetical. Well, that's an issue. So in fact, we never really know if two tests are parallel, but we can get a general sense that tests are constructed or intended to be parallel, that they behave as if they are parallel. And let me give you an example of two tests that are constructed to be parallel. Let's say, for example, that I wanted to create a test of extroversion, that is outgoing sociability. So if I were working in the beginning of the 20th century under classical test score theory, what I would do, classical test theory, what I would do is I wouldn't think about making one test. I'd think, oh, I have to make two tests, two parallel tests. I mean, this was serious business. And it shows how models, theoretical models, can influence empirical research in important ways. So, beginning of the 20th century, if I'm using classical test theory, I'm going to be influenced by that theory to write two tests. So on the left-hand side, I have my original test, and on the right-hand side, I'm writing a parallel test. And what I try to do is I try to write each item so that it conveys sort of the same information as the one on the original test. So on the original test, I asked, do you like large parties? Good test to measure extroversion. Yes or no. On the second test, well, I can't ask that one anymore. So I say, do you prefer to be around people at social gatherings? And yes or no. On the second item on the first test, I say, do you prefer reading to socializing, which is a good test item that measures introversion. Maybe I'm an extrovert, so I'll say no. My parallel item on test X prime, the parallel test, is do you prefer staying home and doing things around the house to going to parties? That's also could be a good introversion item. So I've got an extroversion item, number 1, in both, an introversion item, number 2, in both, and then number 3, do you find that you you prefer to make plans quickly and easily with other people? Yes or no? That's kind of an impulsiveness question. If you like to make plans quickly, you're more likely to be extroverted. And then I've noticed that my items were a little bit longer on the parallel test than on the original test. So this time I try to write something shorter on the parallel test. Do you prefer action to planning for action? Okay. So there are my 2 tests, which I hope will be parallel at the end. I can probably make them a little bit more similar than they seem here. This was just an example, but you get the idea. This is how you create tests that are intended to be parallel. In reality, people spent thousands of dollars to do this in the beginning of the 20th century, sometimes tens of thousands of dollars. And as an historical example, in the most widely used intelligence scale, up through the 1950s or 60s, the Stanford-Binet intelligence test, the test manufacturers created 2 forms, Form L and M. This was required. That's how classical test theory worked. Now later, actually right around that time, mid-20th century, new developments in classical test theory made the development of parallel tests unnecessary. And we'll learn about this when we cover reliability later in this course. But, it wasn't all bad to have 2 forms of a test, because then you could also, remember we were talking earlier when we were talking about the 5 assumptions of classical test theory, that one of the assumptions is you give a test, you have a person take a test over and over again, and the average of those tests is their true score. Well, once you had parallel forms of a test, like 2 forms of the Stanford-Binet, you could give both tests to a person at 2 different times, perhaps. There would be no practice effects or minimal practice effects because the test content was different. And you could get 2 separate estimates of their intelligence score, which would give you a more reliable, better, more likely estimate of their true score than if you used one test or the other. So it wasn't all bad to have parallel tests, and indeed, some test manufacturers still make parallel tests today. But at any rate, this parallel test is an important part of these foundations of psychometric theory, classical test theory. The assumptions of classical true score theory describe this meaning of this observed score, and these 2 definitions, parallel and essentially tau equivalent tests, represent important concepts to further derivations. And those further derivations are coming up in the next video. Thank you very much, and if you have any questions or comments, please do let me know.